Hello and welcome to the Automation Insider. My name is Joe McGrath and I'm from Hy-Tek Intralogistics. Today we're going to try to sort it out and we're going to talk about selecting the right sortation systems for your operation. My guest today is Clint Powell from Tompkins Robotics. Clint, go ahead and introduce yourself.
Yes, as you said, Clint Powell with Tompkins Robotics. Been in the industry about 10 years. And at Tompkins, what I do is I specialize in the sortation systems and looking at facilities to figure out whether our sortation system is a good fit. And if not, what sortation system will fit them the best. So I spend every day looking at sortation and making sure it's the right fit.
Very cool. All right. So I typically call you and ask you like really hard questions about how do I design something that's kind of wild. But today, let's start with a super basic one. What is sortation?
To me, it's taking anything that's in a group and separating it out to where you want it to go next. That's how I think of sortation. So whether that is in a restaurant where you're taking food that comes in, you're separating it out to the tables, or trucks, right? Getting it off of barges, getting it over here, taking it, sorting it out to send it where you need it to go. It's the same concept, whether it's in a facility or not. So I try to look at it that way. Gives me an opportunity to learn from everything I see.
Very cool. Yeah, that's a super good perspective. So it is true that it's also particularly important in warehousing and distribution. And I don't know if you have some maybe even better examples of that, but like bringing things into a distribution center, there could be thousands of SKUs, right? From hundreds of vendors. And those could go to, depending on the network, millions of different orders, right?
Yeah, I mean, compare it to the restaurant idea.
Yeah, that'd be a huge restaurant.
Yeah, it would be huge, right? You're talking thousands and thousands of menu items and compared to 8. So that's, once you ramp it up, how do you do that with people? And that becomes a thing that we'll talk about later, is like, how do you get enough people to make this work? How do you find a big enough space to make it work? All that kind of stuff.
Yeah, well, so I think that's a good question. So you can sort things manually, right? And I think that as long as there have been people with more than one thing, they've been sort of manually sorting stuff, right? You take, I don't know, the 3 objects and you move them out. But at scale, that becomes kind of untenable, right? You have hundreds and hundreds of people. They're tripping over each other. It's difficult to organize. So there's a lot of automated type of sortation. Just off the top of your head, what are some of the big like automated ways to sort stuff?
You have your inline sorters, which will be anything from your shoe sorters to your type of rollerball type sorters. Then you have your loop sorters, and then you have the automated AMR type sorters. The so big ones off the top of my head. Yeah, the robotics type sorters.
I feel like that's a good breakdown of it. Okay, and like, what are some kind of like main KPIs when we're talking about sortation for the rest of the time here that we should keep in mind?
Of course, accuracy is huge. Reliability is huge. It doesn't matter how accurate you are. If you can't keep running, can't stay running, it doesn't matter. And then you come down to your other ones, your speed, and then what kind of weights can you handle, things like that.
Okay, I think that's excellent. So it's got to stay running, because anyone that's ever seen a sorter crash knows that one little oops could cost you an entire day easily. Yes. You got to sort it to the right place, otherwise there's no point doing it, right? You don't want to send the wrong items to the wrong customers. That's not the food I ordered, right?
Yeah.
And then throughput, you have to do it fast enough, right? There's some different process methodologies we'll talk about later on that can help augment the throughput part. But yeah, I feel like those are excellent points. Okay, so now let's talk about sortation strategies a little bit. So you can sort stuff, but there's a lot of ways to do it. I think the default example is like a discrete sortation, right? But you want to speak to the kind of the differentiation between like a discrete and a batch sortation strategy?
Yeah, I mean, if you can get discrete in the space and you can touch an item one time, put it in together with all the other items that need to go to that same place, it's brilliant and works phenomenally well. But as you get larger and larger, you just don't have the space to do that anymore. Then you want to pick and go grab everything that can go together, go grab that, or sorry, not everything that goes in, but everything in a big group of orders. You go grab that, bring it all up, and then somehow through some type of sortation, take all of those items and separate them out into where they're going to go next. So usually we're talking about totes, different gaylords, things like that, but put it together where it's going next, whether that's an e-com order or you're talking about a retail replenishment, wholesale, all kind of the same concept. Get as many things as possible at once and then sort them out to the locations.
Yeah.
That way, the operator's or FTE's not walking around constantly trying to go to that same place 100 times.
Okay, so we can batch or we can discrete pick, and just like for those following along at home, discrete picking is you're picking directly to the order. There's no kind of in between functionality, and you could sort discretely as well, right? So you take one item, put it in one place. It doesn't make a ton of sense. You don't see it a ton, and this is why sortation, kind of another reason that you start seeing it in the warehousing space a lot. And just kind of logically, I wanted to hit on one other topic, and this one is not talked about a ton, but I think it's really important to understand is the difference between like a primary sort and a secondary sort or a tertiary sort. And I think that you guys have some pretty excellent experience with this at Tompkins. But do you want to go ahead and describe like the difference between a primary and a secondary sortation?
I'll let you hit on that one. You deal with the what happens with that and the evaluation of that a little more than I do. Usually, whenever y'all are reaching out to us, we are actually you're telling us what you want to sort and how you want to sort it.
Yeah. Okay. Fair enough.
You do a better job explaining that one.
Yeah. Okay. So typically a primary sort is like the first time you sort something. So let's say you have a huge batch of things and you need to go to like a lot of orders. So I pick 100 units and I need to go to 100 destinations. Well, maybe my sorter can't really accommodate all 100 destinations at rate for whatever reason, right? So I'll sort it the first time through. I'll sort it to one of 3 secondary sorters. So I'll sort a machine to a machine or a process to a process. And I think an excellent Tompkins example of this is I'll sort it on the tables, right? The little yellow trucks running around, and then they'll go hit a put wall. So like I'm sorting it. Technically, I'm sorting it 2 times. And if you want to get crazy, like you could have some pre-sorts in the picking process that would make it a tertiary sort. But this strategy of kind of hierarchies of sortation allow you to do a lot more with a lot less equipment.
And we see this like last mile type stuff a lot where we don't have a lot of space. So we have to bring it in. We need to sort it into the zones that it needs to be delivered out to, then sort it again into the final packages to go to those blocks or different areas. So we see that really often in different types of sortation.
Yeah, and like I've even seen it like across time, right? So maybe you sort the first wave and then everything is for a later wave kind of gets put to the side and then you rerun that through the system. So, in a sense, you have like a temporal secondary sort. Those systems are admittedly extremely complicated and I don't love them. But if you're really like a limited budget or limited space, like it could be something to consider.
Yeah, I mean, I have a couple I'm looking at now where the space doesn't allow for it, right? There's just no way that you could sort to all the locations. I need 2,000 plus locations and they have less than 10,000 square feet. Like that is just, that doesn't work. So you sort it out into like 6 different zones and then you take those zones, run them back through again to sort out into a couple different locations a piece. And that actually works out really well. More complex, as you said, but somehow you got to make it work in the space you got. And you also can't have people walking up and down aisles with that many locations. It just doesn't work.
Yeah. There's practical limits to what these things can do, so you can augment with the process. So I think that's fantastic to know about. And then I'll let you give some kind of examples of this one, but there's different reasons to sort things. And I think this is probably a good thing to highlight. In one building, I've definitely designed a single operation to have 3 or 4 distinct sorters, or one sorter with 3 or 4 distinct sortation processes kind of within it, right? I don't know if you want to speak to that, like, inbound sorting versus outbound versus routing.
I mean, your inbound is common, right? You have stuff coming in from different areas and you need to get different, whether it's because of speed or because of type of item, they need to be stored in different areas. Like some things are flammable. They can't go in ASRS type systems because of that. Different things like that, weights, there's all kinds of different reasons. But you can bring stuff in, sort it out, so everything that needs to go be stored the same is sitting in the same location. So it makes it much easier for whether it's your fork truck drivers or you take conveyor and put it into the area, it's ready. Then you mentioned your outbound sortation, shipping, everything doesn't ship to the same place as a general rule. So you got to somehow separate that out to make shipping easier. And then you have all of your sortings that go on in between that. So you have a lot of unit sorting, and all you're doing then is trying to fulfill orders. You can fulfill orders by bringing stuff to people, letting them fill 4, 5, 20 orders at a time by putting stuff in it. Or you can fill hundreds of orders at a time by bringing more product to that person, letting them put it on some type of sorter, and that sorter will take it to the destinations. We do a lot of unit sorting and work with y'all a lot on unit sorting, because it's just a phenomenal fit. Whenever you bring a whole case of items in and you sort that entire case, nothing's simpler or works better than that if we can do it.
Yeah. So I think what Clint's talking about is, like we have a couple of processes where, a lot of times we'll have an ASRS or a storage system right next to a Tompkins T-sort, and we'll take things right out of the ASRS and we'll induct it into the T-sort. But there's a world where if you have enough destinations, or if your wave is large enough, right, or you can create a sortation batch that is significant, you can just skip the ASRS altogether, and you could almost come across from inbound or from your reserve directly into the system and sort it. So it kind of creates some very interesting opportunities.
We have some cross-dock type situations where we're doing an inbound sort to sort it out to get it to going on the right lanes for the cross-dock. Then we would sort those down into a packing station, which I know packing stations aren't as common in a cross-dock, but it does exist. And then come out of the packing station, and we're doing the final sort into the final destinations, and everything being handled by Tompkins robots, different types of robots, but by our different robots.
I think these omni-channel sort of operations are where you start to see all of these like different sortation methodologies happening simultaneously.
Yes.
It's possible to do this without robotic sortation, although admittedly it's a lot more difficult. But I've seen some, like, air quote, ship sieving sorters, where the shipping sorter and the receiving sorter, the inbound sorter, are the same loop. They just have different diverts, and they kind of share a recirculation.
Loop sorters. I mean, getting multiple items inputted at different times and clearing them out makes them a lot more efficient. I mean, it's one of the things you try to look for when you're doing one. Spent a lot of time doing those before I got here. So
yeah, they're tricky because like if that recirculation line fills up, all bets are off. Okay.
And there's a reason why trains are still a great way to ship things, but people use semi trucks instead. One thing goes down on a train, you're in trouble. One thing goes down with a semi, the next one will pick it up. You're okay.
Absolutely. Okay, so let's I think this is a good segue. So let's talk about some key consideration. We talked about what sortation is. We talked about why you might want to sort in a building. I think a lot of people will be tuning into the podcast because they already know that they need to sort something, or they need to figure out how to get it from point A to point B. So how do you choose the right sortation system? What are the key things that you need to consider? When you're kind of looking through the data.
Yeah, the first thing you look at, as far as what I look at first, rate and weights. How heavy are the items, and then what kind of rate do you need to hit? Those are big ones to determine. That weeds out a lot of different sorters, just those two things. Once you get to that, then you look at space, you look at what type of items, what's your SKU count. You have a lot of SKUs to a lot of different orders. Is there any commonality? All of that stuff comes into play. And that gets a little more complicated when you start digging into all of that kind of stuff. I mean, if you have 5 SKUs and that's all you have, then just bring them to a person and let them fill out orders. Don't get any kind of sorter. But that doesn't exist hardly ever. I mean, we see it every now and then, but it's not common.
What about trying to consider flexibility or future growth with the sorter? Is there any pieces of data that you try to seek out that speak to the need for that, or is that typically consideration you guys have?
So for us, we always like to design a phase 1 and a phase 2, knowing that our sorter is so flexible that if phase 2 completely changes, it doesn't matter. We just adjust and tack on different areas. If you're not using a robotic modular type system, you've got to plan for phase 2 and hope that you get it right. And in my experience, no matter how good the consulting or other team you have involved trying to plan for the future, things just change. I mean, we saw this in 2020 when COVID hit. I mean, everything completely changed and nothing worked the same anymore. And everybody's trying to figure out what to do. And that's actually what sent me to Tompkins is, hey, the ability to adjust is huge now. We got to be better at that.
Yeah. So, and you guys have a ton of scalability kind of components sort of native to that system, and a lot of redundancy, which is pretty excellent. So in terms of what do you think about when you look at order composition? Does that ever come into play when you guys are sizing or looking at what type of sortation processes you need to put into place?
Yeah, so we try to be able to handle any type of order composition. So we have a bunch of different types of locations we can go to. I mentioned earlier Gaylords or totes, but we also can go to chutes, so it can be palletized off the chute, different things like that. And we also have our T-Sort 3D, which is essentially a put wall that can be a mobile put wall, can be pulled out. So like e-com, small items, it goes to that. So we are definitely looking at all of that. We try to be flexible enough that we can handle any type of order composition. But if a lot of sorting is, like you mentioned earlier, a lot of single line, single unit type orders, it doesn't make much sense for that to go through a sorter. Unless directly out of an ASRS and you can't do anything else with it, it's a small percentage, sure, but generally don't send that through a sorter.
Yeah, it becomes a routing exercise more than...
Yeah, it's adding touches. It's really not the most efficient way.
All right, so those are kind of the main things you want to look at. Are there any additional like business requirements that you guys typically see customers talking about when you're trying to design a sortation system?
Our sorter was originally designed around the idea of clothing. So that was the original design. Small, flat items, pack a lot of them in, made a lot of sense. We've had phenomenal success in the pharmaceutical industries because we don't have missed sorts. The robot goes, the robot stops, the robot dumps the product. You're not trying to hit something as you go running by it. It just is much more efficient that way. And the missed sorts are essentially non-existent. There's a possibility that a person does not put the product on the sorter correctly or on the robot correctly, and in that case, it can fall off. We have a tilted tray. We really don't see things fall off, but there is 1 in a million or so that somebody doesn't put it on there or hits a button without putting it on there. But once the product is on our sorter, it pretty much is going to go exactly where it's supposed to. So accuracy becomes important. Like you mentioned, pharmaceuticals just pops in my head because it's a common thing for us. I mean, that is huge. We hardly have any missed sorts.
Well, it's a super critical. It's a super critical application too, right? Like sending the wrong medication to the wrong destination could be fatal. So it's a huge no-no. And just for what it's worth, like I think one of the linear sorters are kind of the poster child for this type of error. But you put it on and it vibrates a little bit, and a lot of times these sorters are set up to have encoder pulses, and so I know where the product is on the sorter because of how long it's been there and how fast I'm going. So I'm kind of dead reckoning where the thing is, and I use some photo eyes and I try to divert it. But if it shifts too far out of that range, like you can sort it down the wrong lane, or you can smash the item, right? Or you can just send it, into oblivion, like not even down a chute. So these are all like real like kind of problems. I think that the tilted tray kind of concept is pretty clutch in terms of like having a positive control over the item.
I mean, obviously, pharmaceutical type stuff it's huge. It's critical. You cannot have missed sorts. But I mean, even when you're talking clothing or something else like that, it gets expensive if you ship the wrong item to a person and have to get it shipped back. Like returns are expensive anyway. Why add to what you don't have to have?
Yeah, absolutely.
We do pride ourselves on having no missed sorts.
Do you ever find that you're like in a conversation where like it's a debate between like throughput and accuracy, or is that pretty much like a non-starter for you guys?
We don't really have that issue. I know that's very common, but our throughput rate can be extremely high. I mean, on one sorter, we easily can hit 15,000 sorts an hour. If we need more, we add 2 sorters. I mean, that's the same as anybody else is going to do with any other kind of sorter. So when it comes to throughput, we don't have an issue, and our accuracy never changes. I mean, the item is scanned and told it's put on the tray, and then it goes to where it's supposed to go. That doesn't really change. So our accuracy never gets better or worse. It's always great. And then throughput happens.
Well, so you kind of mentioned a little bit, but some sortation projects I've been part of are actually intended to handle returns like expressly. So we didn't sort it wrong, but for whatever the customer doesn't, it's the wrong color of green and it doesn't match my eyes, and I'm going to send it back, right? Like, could you talk about like a returns type of sortation system? Like, have you ever seen like applications like this, and what do you do differently, and what do you do the same?
So I've been working a lot on returns recently, trying to figure out 2 or 3 different options for returns, and like how can we really dive in on these and really try to solve this problem, because it is a major issue for everyone. I mean, nobody likes them, nobody wants to deal with them, but you've got to do it now. Amazon allows free returns. If they're going to do it, everybody else has to too. So we're looking at a couple of different options for returns. One of them being sorted into Gaylords, take it to the aisle that stuff is put on, and once you take it to that aisle, let a person come and individually sort things out through that aisle inside the picking area or wherever it may be. Obviously, with most returns, there is some kind of grading that has to happen. We can grade at our induction, or it can be graded upstream, just depending on the rate of the return. So if it's a high rate and the customer has a lot of returns, it makes more sense to grade earlier. If it's a pretty low rate and a person can grade, hit a button and give us the information, we can sort based on grade and based on the product. So first thing we look at a lot is the Gaylord option. Then we look at, I mentioned earlier, the 3D, so the put wall type setup. So we can sort to a lot of totes in a small footprint. So that allows a lot of returns, say 400 different locations that those totes need to be taken to. We can sort to those 400 locations. Anything that's over those 400 locations, we can send it to a jackpot location, which for us, something that should be mentioned is we don't really need a jackpot. The product is scanned when it's on this order and takes off. If there's not a location for it to go to, the person has to take it back off and redo it. We can always send it to a jackpot, but when it comes to returns, there's, say you have 400 locations. When you hit that need for a 401, just sort those to a Gaylord, and like we mentioned earlier, you can always bring those back and resort. So that's really common. We're seeing that the payback works really well, and the thing I'm seeing really common is, well, there's only enough items coming back to sort if you did it over the full shift. Well, that person can only sort it 200, 300 units an hour at max. Well, that's limiting that person, and you're paying somebody to sit around and twiddle their thumbs a lot. And as you know, that's never a positive. So what we've been talking about, we've been implementing is actually bring that stuff in, those products in, sort at as fast as that person can do it, usually around 800 or so to 1,000 units an hour. And then go pull that same person go pull items off or pull totes off and then come back. So 30 minutes on, 30 minutes off. And that way that person is being much more utilized. And one, they're not standing still. They're probably going to enjoy their life and enjoy their job a lot more because they're getting to do more things. But then we found that works much better, and the operation seems to be working a lot better.
So I think this is an interesting topic that I always end up getting into with sortation. And I think everybody kind of gets sucked into this one because it's the part that you touch the most. So like induction stations and like workstation design. I know that you do a fair bit of consulting me on this. I don't know how much you talk to other folks about it, but like when you're designing a workstation, or an induction station, like what are some of the kind of key takeaways that you want to make sure you incorporate to, like, at some point in time, this is going to be somebody's like life, right? They have to stand here and work at this station. Yeah. So what do you consider when you're doing this?
So certain end customers have different requirements. So the first thing we want to do is make sure we're accounting for their requirements. We don't put our thoughts ahead of what someone's requirements are. But the next thing is ergonomics. You can't have someone reaching above their shoulders or bending below their waist constantly. They're going to start having soreness. You think something that weighs a pound would never cause soreness because you can lift it and it's no problem. But you do that 10,000 times a day, it's going to get to be a problem. Do it weeks and weeks after. So we try to make sure that ergonomics are there. If there isn't a great way to do that, or if there needs to be a way to make sure that the product gets on the correct level of our sorter, we have an induction lift where that can be adjusted and can be made the perfect height for any operator. So it's really important there to make sure that the ergonomics are great. We want the totes to come in at an ergonomic level, totes or however the product's coming in. And we want that to be ergonomic. We don't want bending, we don't want twisting, we don't want lifting. All of those things tend to cause issues later on. And we talk all the time about payback, but a big thing in payback is having to pay people because they got hurt on the job is a big expense. So if we can make people's lives better, make sure they're not sore, make sure they're not hurting, not only are they happy or working, but the expenses of dealing with lawsuits don't exist anymore. And those are big paybacks that sometimes aren't hit on and aren't looked into.
Yeah, it's interesting. Like those get ignored during ROIs, but they're very real costs of touching a box 10,000 times a day, man. It's intense. That's cool. You mentioned cross-dock sortation a little bit. Give me an example of a cross-dock sortation that you've set up, via robotic sortation.
So, got to make sure I don't mention names here, but
yeah.
Yeah. So, a common one that I recently worked on that's moving really well. Everything came in and it was loaded into the truck to make it the most efficient way to get from the manufacturer to that facility, which means it wasn't on pallets. It is a fluid-loaded truck.
Yep. So containers, you can maximize the container. It's real painful.
It's packed in. I spent my childhood loading trailers full of wheat straw, so it gives me nightmares every time I see that. But that's a whole different conversation. But yeah, so in that situation, some type of flexible conveyor, some type of conveyor has to go there to help get that stuff off of the truck. It just works better. So we actually did that and used our floor robots, our T-sort posts, to take those cartons and sort them out based off of where they needed to go, because manufacturers sending a bunch of things in. So we took those T-sort posts and sorted those out based off where they needed to go. And then once they got to that location for storage, even with a cross stock, it's not all comes in and goes out the same day. Sometimes it's stored for even a few hours or whatever. So put it in a storage location where it can be fed back out into some packing stations. Those manufactured cartons could be opened and split into the orders they need to be split into. A lot of times this is getting ready for line side delivery and for the next step of manufacturing. Okay. I think the car industry, the bolts that go on the tires or your lug nuts, they don't get shipped with the tire, but they need to be there whenever it gets put together.
Yeah.
So got to get all
pre-kitting going to work.
Yeah, so pre-kitting it, got everything pre-kitted, and then used our T-sort robots to, in some situations, to sort those out. So like 6 lug nuts go with the tire, right? To sort everything together, or to sort out the final packages. So we actually sort it out to the packing station, let them pack it up into totes for line side, and then put it on the next set of our T-sort robots to handle it, to take it, put it out to some gravity conveyor to be palletized to ship to the actual next step in the manufacturing process. Cross stock, but in a manufacturing world, it's a little different, but same concept, came in and back out.
All right, very cool. You kind of mentioned, so you talked about the T-sort post, and I thought, hey, this is probably a pretty good segue, but like in terms of robotic sortation technologies, there's actually a lot of ways to do this. Can you guys kind of go ahead and like just characterize like the main like types of robotic sortation systems that are sort of existing in the world today?
So I think some of your oldest ones would be your robotic arm sortation, where product comes in, grab it with a robotic arm and sort to as many places as you can reach. Small products, small containers, you can reach quite a lot of places. So that's probably one of the oldest ones. I mean, robotic arms have existed for a very long time at this point, at least in our world. It's a very long time. And then you have what I call your stationary ones. So essentially a conveyor or a shuttle running through, and they're sorting off to a bunch of different levels. Usually a conveyor runs into a shuttle grabs it, goes to a bunch of different levels. Okay. Great if you can get the throughput through there, and if everything balances out well. When they do, they're phenomenal sortation. And have us and a couple other companies that make a floor robot, which we call our T-sort post. It's running around. It's a pedestal robot, pretty heavy duty robot, can handle a pretty good bit of weight. A lot of times used in shipping sorting, taking from pack stations, things like that. So that's a really common one. And then we have our tabletop sorters, which is the really common one everybody associates with us, which is our T-sort. And we're kind of the only ones doing that. I mean, I know some in other countries, but when it comes to here, we're the main ones doing that. And that's just a much higher speed sortation than your other types. That's the main robotic sortations that I see or we compete against regularly. I know there's some others out there, but we just don't see them as often.
Yep, there's some like there's a kind of a hidden sortation you can do with like an ASRS. So there's a lot of robotics-based ASRSs. These are not obvious, but you can essentially sequence it out in such a way that it arrives at whatever that destination is, sorted, air quotes. Yeah. This is like it's interesting because the balancing and like understanding like all the math behind like is this the right size to do this much sequencing is pretty important. Like, yes, putting it out in sequence is a lot harder than just putting it out randomly.
I mean, it takes a lot of work, and the ones that are able to do that, I know you work with a couple of them that are very good at it. It is brilliant what they're able to do.
Yeah, but sometimes it still makes sense to put it through a sorter. It could still be less expensive to do it that way. So there's definitely a lot of research you got to do when you do it that way.
And I think the combination is going to become more and more of a thing. I think sequencing to discrete, but also batching for different types of orders and stuff is just going to become more and more of a thing as we go forward.
As far as future, like the future of sortation, like what do you see in like the next 5 years as like the kind of big game changers that we might expect?
I think we're going to start figuring out ways to sort and store a little better. Right now, we see a lot where you sort and then go store it or go buffer it in some type of crane system or some type of shuttle system and wait for the right truck to show up or the packing stations to open up or the other products from other areas to be ready to marry up. I think we're going to start seeing different types of sortation where it can be sorted, box complete, store it right there. Because there's no sorter, I mean, we're decent at it, but nobody's great at using the vertical space with sortation.
It's like an ASRS sort of characteristic.
yeah, just add something like that, adding to it. There's a couple videos out there of different people doing it, looking at different ways of doing it, but it's coming. I think that's a big one that's coming. I think just like people don't ship as much by train now, you're tied down sorters that take so much maintenance that you can't let any screw get wrong because the whole sorter will go down. Everybody used to, back when I first started this, robust was the word. How robust is it? Can it handle everything? And I think now we're going to have to start talking about reliability. How reliable is the system? How much downtime does it actually have? How much maintenance does it take? If one part goes down, is the system down, or can we keep running? I think those are the things that are going to start becoming more and more. I mean, you see it with the storage, right? Everybody went away from crane systems. Everybody's using some type of robotic type ASRS system now, whether it's a shuttle or whatever it may be, because you don't have a single point of failure anymore.
Yeah, there's not any like everyone's like, wow, how often does it go down? I'm like, it never really goes all the way down, right?
Yeah.
And so it's not like this mean time between failure. Like, sure, you'll have those, but it's not quite as meaningful. I think OEE, like, it's, you learn about it in school, but you never use it. That is becoming a much more potent measure of how effective, how reliable these systems are going to be, right? Like, sure, like a one bot went down. What does that actually do to your overall throughput? Well, it may do nothing. It may be negligible, right?
Do anything. We have extra there for a reason.
Yeah. And like I think that's a great point. But like the vast majority of OEMs and system designers, there's always like a little extra padding in there, right? Everybody wants to be kind of safe. Yeah, that's extremely common. Nobody talks about it, right? So
we work commonly. We work a lot with ASRS type systems, like we work with y'all a lot. And the nature of an ASRS system to a sorter is a tote arrives, and a person picks a bunch of that tote. Then they wait for the next tote. Yep. So if our system was based on just what our robots could do, then we wouldn't actually ever hit rate, because there's that gap in between where a person can't hit the rate that our robots can anyway, but theoretically, the person's waiting on the next step. So we have to have something in there to cover for that. And we have to make sure we're buffered and doing that correctly. And we run most analysis and all that kind of stuff to make sure we're smooth. We handle all of that, but it's always something to keep in mind.
Well, Clint, thank you very much for taking the time today to talk with me about sortation. I know it's a really big topic. We only kind of scratched the surface. This is a huge part of what we do every day. So we might have to get you back to beat up the topic some more in the future.
I'm happy to. Anytime you need me. I won't be on here more.
All right. Well, thank you very much for tuning in to the Automation Insider. Reach out to Clint if you have any sortation questions, or call me up. And absolutely like or follow us on YouTube, and we'll see you next time.